All right, so we've talked about sine and cosine graphs now. All right, so in this section 4.5, we're going to talk about the tangent graph. Now I know it says over here or up here that cotangent, secant, and cosecant are included, but we are not going to talk about those because, quite frankly, they're not that important, at least for our purposes in this course. So, taking a look at the tangent graph. All right, so here's our analysis. Now you'll notice the graph looks a little different than sine and cosine. So the domain are all real numbers except odd multiples of pi over 2. So this is what they're talking about. Pi over 2, 3 pi over 2, that's a pi, that's a terrible pi. 5 pi over 2, 7 pi over 2, dot, 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 dot. Okay? Odd numbered multiples of pi over 2. Now the range in this case is all reals. Okay? It's continuous on its domain. Okay, so whatever x values are good, that's where it's continuous. Now, I would argue that it's not continuous because of the asymptotes, but I'm not worried about that. It's increasing on each interval in its domain. Okay, so from pi over 2 to 3 pi over 2, increasing. From 3 pi over 2 to 5 pi over 2, increasing, and so forth. Symmetric with respect to the origin, which means it's odd. It's not bounded above or below. There are no extrema. There are no horizontal asymptotes. But the vertical asymptotes, there are many. X equals k times pi over 2 for all odd integers k. In other words, these are all examples of vertical asymptotes. Again, the end behavior does not exist, okay? Because of the asymptotes, because of the several branches that there are, the several portions of the graph, the function values continually oscillate between negative infinity and infinity and approach no limit. Here's what I'm talking about with this, guys. Okay? Let me show you. So this is pi over 2, pi, 3 pi over 2. My increments are in pi over 2. Okay. Now, there are vertical asymptotes at all of the odd numbered pi over 2's. Okay. So if I went on the other side, negative pi over 2. All right, and then it would just continue to the left. Now, smack dab in the middle are the points where the graph crosses. Here, we'll go one more out here, 7 pi over 2. So our graphs are just this curve over and over again. Okay? All right? So the asymptotes are at the odd-numbered pi over 2's, and each part of the graph crosses at a multiple of pi, or at a pi. Notice, pi, 2 pi, 3 pi, 4 pi would be out here. Okay? So the graphs cross at pi, or whatever number pi it is, and the asymptotes are at the odd-numbered pi over 2's. Okay. Says to describe the graph of the function y equals negative tan 2x in terms of basic trig function, and then locate the vertical asymptotes and graph 4 periods of the function. Now, first things first. Notice the 2 is in front of x, so that means that b equals 2. So we have a horizontal shrink by a factor of 1/2. Remember, our horizontal shrink and stretch are reciprocal of whatever b is. Vertical, you keep the number. Horizontal, you flip it. Okay? And then the negative out front means which means we reflect over, I'll get it out, the x-axis. Now that can be in any order you want. Now, vertical asymptotes, okay, are now multiples, odd multiples, I should say, of pi over 4. Now you might say, well, how'd you get pi over 4? Well, normally they're odd multiples of pi over 2. But because of this horizontal shrink by a factor of 1/2, pi over 2 times 1/2 gives me pi over 4. Now it says to graph 4 periods. That means 4 cycles, kids. Okay, let's see. Now, instead of pi over 2 and all that, let's do this. Pi over 4, pi over 2, 3 pi over 4. Now my increments change, okay? In this graph, I went by pi over 2s. In this graph, I'm going pi over 4s because that's where the vertical asymptotes are. 5 pi over 4. Stretch this out. 3 pi over 2. 7 pi over 4. 2 pi. Hopefully that's enough. Actually, we'll go on the other side here and do a negative pi over 4. There we go. So these are all of our asymptotes. Odd multiples of pi over 4. Okay? And the graph's going to cross. Now remember, for the basic function, the graph crossed at pi, 2 pi, 3 pi. Now, okay, since we shrunk the graph, that means that instead of crossing at pi's, they're crossing at pi over 2's. Multiples of pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi. Now, notice these curves right here. So this curve right here is the normal curve for tangent. But we are reflecting over the x-axis, so now they're upside down. So not only did they shrink, now it doesn't look like they shrunk because I enlarged the graph. Those curves are upside down. And by the way, I'm just going to go ahead on the record. Those are pretty good curves, okay? For stylus and my sloppy handwriting, those are great curves, okay? So you could give it up one time for me, okay? Thank you for the applause. So here's our graph. There's 4 periods, okay? And we did the horizontal shrink, and we did the reflection, and we have our graph. So there you have it. Very short section. Not a lot of problems. We're only worried about tangent. I'm not worried about the other 3. Sine, cosine, and tangent are plenty.